Welcome to ASOC Tutorials India program. And if you remember in the past, in session 1, I have already covered passive section. In session 2, already I have covered active session. And in continue to passive and active session, today I am going to start communication system. And this communication system includes radio receivers, their properties, characteristics, transmitter, principal, other parameters, radio propagation, day-night effect, aerials, antennas. So combination of all will go continuously. Before I start today's session, I want to clear you that these tutorials are not made for any kind of competitive entrance exam like joint entrance exam or similar. It is a purely ASOC examination activity, and this exam is normally not asking any kind of calculation, formulas, details, proof, etc. It is a purely objective type, choose the right answer type question answers. So these tutorials are only for qualifying amateur station operator certificate examination, which is conducted in India only. So going to start today's session. First, you see, to complete a communication, we need a person who is speaking and other person who is listening. The person who is speaking, we may treat it as a sender or speaker. On other side, the person who is listening, we can treat as a receiver or listener. The person who is speaking, we can treat as a speaker. In between, there is a path, maybe air, mobile communication, landline, video call, whatever may be. On other side, there is a listener who is receiving your message communication. If you see from other point, the person who is a speaker or sender can be treated as a transmitter. In between, there is a propagation conditions because we are going to discuss on this subject. And other side, there is a person who is receiving or listening your message, we can treat as a receiver. This may be one way or two way, simplex or duplex. But when we come to the term transmitter, we will discuss AM transmitter, CW transmitter, FM transmitter, and other parameters. When it coming to receiver, we will discuss TRF receiver, SHR super heterodyne receiver, Morse CW receiver, and communication receiver, and other parameters like characteristics of a receiver, etc. When it comes to the propagation, we will discuss ionosphere layers and day-night effects and other parameters. When we are coming to the sender side, there is a need a speaker or microphone, same way on other side also, and of course there is a need of antenna and aerial also, and different aspects are there. So we will discuss everything one by one, and this entire system is called communication system. And today I have to discuss modulation and need for modulation. But here, first you need a recap. You have to understand what is amplitude, frequency and phase. Already they are discussed briefly in AC Fundamental SD16 tutorials. So kindly see that part first so that it's easy for you. If you see a sine wave or sinusoidal wave, the highest value is called amplitude value, and distance between peak to peak is called wavelength, or you may use for counting number of circles per second as a frequency, or time period, time taken to complete a one cycle. And same way, movement of armature or rotation of armature, position of armature, everything you can treat as a phase. It is going positive or negative. It is very important to understand. Now, first question is coming here. What is signal? Here you have to understand signal is a source of energy which transmits some information. This signal helps to establish communication between a sender and a receiver. An electrical impulse, or I can say EM, electromagnetic wave, which travel a distance to convey a message. A audio communication can be termed as a signal in communication system. Just note down it. Depending on their characteristics, signals are mainly classified into two types. One, analog signal, a continuous time varying signal which keeps on varying with respect to time and according to instantaneous value of low frequency or audio frequency signals. On other side, it is a digital signal, a non-continuous in form of signals which has individual values denoted separately, which are not based on previous value as if they are derived at their particular instant of time. And here one thing you have to understand. This signal may be analog or digital, no matter. But if it is repeating its pattern over a fixed time, then it is called a periodic signal. This signal has its pattern continues repeatedly and it is easy to assume or to be calculated. This is periodic signal you have to understand. Now going next more further from signal. First you have to understand why modulation. It is very simple. You have to understand the low frequency signal or audio signal. It is not easy to broadcast or transmit because of several reasons. Number one, if you know how to design an antenna and you try to calculate using lambda is equal to c by f, surprise, the antenna will be such a huge, it is impractical. And same way, if you try to calculate the height of antenna for optimum use, you will surprise it will also impractical to use antenna such a height. It is not easy. So what we need, we have to increase the frequency such a way that antenna height, antenna length should come down. It is possible by increasing the frequency and same time we can impose low frequency on high frequency so that we have all information of low frequency on high frequency and this high frequency carry all requisite information whatever needed to broadcast. Here you have to understand that low frequency is not practical to transmit but high frequency which is carrying information of low frequency is easy to transmit and it is taking very less size, economy and comfort. So for this purpose we need a modulation. Modulation means we need a frequency to impose on high frequency so that resulted frequency will go for long distance and this process is called modulation. Just going further, modulation is the process of mixing a low energy message or signal with the high energy carrier signal to produce a new high energy signal which carries information to a long distance so that the transmitted signal continue to have all the requisite information contained in the original audio message signal. Here I am using the word audio because that is our first motto, but if you see another point, video and other data will come later, but for amateur radio our intention is audio. So modulation in other words I can say is a process of changing the characteristics of amplitude, frequency or phase, anything possible of the carrier wave higher frequency in accordance with the message signal. This message signal low frequency or audio frequency. So a device that performs modulation is called a modulator and opposite to it reverse is called demodulator to get back the audio signal from modulated signal. Going next, two signals are involved in modulating process that you have to understand. One is information frequency, I can say low frequency. Other is carrier frequency, I can say high frequency. If you see the diagram, this is low frequency because wavelength is very higher. On other side, second one I am taking high frequency. High frequency have very small wavelength and when I had two frequency I am going to modulate it. Result, I have three parameters: frequency, phase and amplitude. I can allow one parameter to change and I can constant other two parameter. Example, I am allowing amplitude to change but not allowing phase and frequency to change, keeping them constant. Then this kind of modulation is called amplitude modulation, and my maximum intention will be on amplitude modulation because it is easy. If you see the diagram, modulation of these two are on your screen, such as the frequency is higher but amplitude level is as per low frequency. So all information is available in amplitude, but the overall frequency is higher, and this is called amplitude modulation. If you see this amplitude modulation along with other two, just I'm showing you, the result is very clear. The information is carrying on amplitude in between modulated signal, and frequency is going as per RF carrier signal. And this one I hope is much easier for you to understand how this amplitude modulation look like. Now going next, frequency modulation. Frequency modulation means I am allowing frequency to toggle or frequency to vary with reference to low frequency. Means when the frequency is at higher level, the lambda wavelength will be smaller one, but when it is in lower side, this wavelength will be higher one. Just I'm showing you, if you see low frequency, the moment it is on high level, first I'm bringing in between so that you can understand. Now you see, if you see both waves, low frequency in the top and amplitude that frequency modulation in the middle, you may observe when frequency low is higher, wavelength is smaller. Now again, if you see, when this frequency at downside means lower, the space or gap between modulated FM is also high. By this way you can observe how this one is working. This is FM. Only one PM, phase modulation or pulse modulation, I am not going to cover this time. I may cover some other time because that is required for digital communication. That is toggling the frequency modulation when the moment phase is changing. But overall it is very similar to frequency modulation. So I will cover this topic in some other time. Saving time, recap, modulations are mainly of three types: amplitude modulation, frequency modulation, allowing frequency to vary, keeping constant amplitude, and phase. Phase modulation, allowing phase to toggle but keeping amplitude and frequency constant. But one thing here you have to remember about three are analog modulation. They are maximum required, whereas now it is a time of 21st century digital communication, and digital communication is required digital modulation such as ASK amplitude shifting, FSK frequency shifting, PSK phase shifting, QPSK quadrature phase shifting, and angular modulation, and so many things are there. Of course, our so many modes are running on FSK, BPSK, binary phase shifting, SSTV, MNSTV, and so many things are running. So once you have a license in your own, then it will be good to discuss about digital communication. Not now. Present, keep your focus on qualifying ASOC exam first. And just recap on amplitude modulation. Amplitude modulation is a modulation in which the amplitude of the carrier wave changes according to the instant amplitude of the modulating signal, keeping phase and frequency as constant. These two already explained. Frequency modulation means changing the carrier of frequency, other to constant. Phase modulation means phase of the carrier waves will change or toggle, other to constant. Now again coming back on amplitude modulation, ITU, International Telecommunication Union, has designated different type of amplitude modulation: dual sideband, single sideband, and there are several variants like lower sideband, upper sideband, single sideband suppressed carrier, vertical sideband, single sideband reduced carrier, etc. These will be discussed when transmitter, receiver, and other parameters will come. Radio emissions are defined with an alphanumerical code, and these you note down because they will come in exam. Example, A1A is a on-off key carrier, no modulation, only high frequency carrier wave is going and there is an interruption using Morse code. So result, this carrier wave itself only going in Morse code. A3 is a double sideband with full carrier dual sideband, and this is AM broadcasting. You can listen in AM radio. J3E is a single sideband HSP suppressed carrier. R3 is amplitude modulation telephony. J3 is also telephony single sideband, but here with vestigial sideband slightly part of carrier also there, but in J3A it is not there. F3 first letter is F, it is a frequency modulation, and number 3 is telephony, and number 1 is Morse code. So wherever you see number 3, A3, J3, R3, they are all telephony. And F2D, 2 is a digital. F is frequency, and this is frequency shifting audio tone, and this one is used for data, packet radio, Amtor, Pactor, and other kind of communications. This is digital. Going next. What are the advantages and disadvantages? First, advantages. In an AM, it is very simple to implement. This modulation circuit required very few components, only one simple diode OA79 and one small capacitor ceramic is enough to detect. In case of FM, there is a need a big circuit. AM receivers are very cheap because there are nominal component and very simple diagram. It is very economy, but disadvantages also there. It is not efficient when it comes to the term of power. I will explain in later slides. It is not efficient in the term of bandwidth also because bandwidth is dual of audio frequency, and both bands, lower side and upper side, carrying same information, and carrier itself have maximum power but no any kind of information. And this AM is prone to the high level of noise because noise is carrying on amplitude, and this modulation itself is amplitude. So when this noise is coming in amplitude, this is amplifying in further sections and it is noisy. And AM detector is also very sensitive to it. So removing noise from AM is not an easy task. Here you need to learn one term, spectrum. The spectrum of amplitude modulator is related to the sidebands and are generated, and hence is the side bandwidth. So spectrum is whole chunk of frequencies, and bandwidth is the starting to ending required of frequency band. This difference you have to understand. And one more term, modulation index is defined as the ratio of the amplitude of the modulating signal and the amplitude of the carrier signal. This is very important, and this modulation index is also known as modulation factor, and this modulation coefficient or degree of modulation, they are all similar. And bandwidth is a complex signal like AM is the difference between highest to lowest frequency component, and it is expressed in hertz. And this bandwidth is very important because this one deal with a communication channel or band or communication. So one thing in AM you have to understand, the bandwidth is a difference of both and sum of both and different in between. Means carrier frequency plus audio frequency different with carrier frequency minus audio frequency, and total difference is 2 times audio frequency. It is dual of audio frequency. It is very easy to understand. And this BW means bandwidth in AM is much less with respect to FM frequency modulation. It is 2 times only, as already I have, but in FM it is very large. It is depend on index, modulation index. It is very wide, so many spectrums, so many bandwidths are there, so many channels are there, and the number of sidebands in AM is fixed too, but FM there are so many. When it comes to the terms of Efficiency and power in AM, yes, a big part of energy is wasted in carrier only where information is not there. But in FM, it is creating so many side bands and all bands are carrying good information. So it is very useful and efficient. And application point of view, medium wave or short wave, your radios you are already listening in broadcasting, but it come to the term TV, video part is coming in AM, and same time in television, audio part is being used by FM. But FM radio broadcast also you have listened. Now you see, when we are going to modulate two frequency, carrier and audio, results are two frequency, sum of two Fc plus Fm, difference of two Fc minus Fm, and carrier itself. So we have three components: unmodulated carrier, carrier frequency, upper sideband, sum of two, lower sideband, different of two. And total power in AM is divided in carrier frequency, lower sideband and upper sideband. Everywhere power is distributed. When it is modulation index is 1, or I can say depth is 100%, then you have to understand it will take, sideband will take just only 50% of the power, and voltage 50% voltage they will take, but overall power will be 25% because V is equal to I square R. So each sideband will get 25%. That you have to understand. How I have given simple equation to you. Examiner will not ask to you. Modulation 100%, power 100 watt, power in sideband is power carrier. This max is 2 divided by 4 is equal to 25 watt. Already I have explained you. Overall bandwidth is twice of top modulating frequency. Already explained you. When it comes to the term efficiency, efficiency is term a ratio of a transmitted power which contain the useful information. Here it is very complicated to understand because 25% power is going lower, 25% power is going in upper, overall 50% power is going. But carrier is also carrying frequency. So total is how many? 50 is that one carrying, carrier is 100% carrying. So this is 150. So if you see from other point of view, 50% power is going inside bands, 25 in one, and total if you calculate it for calculation purpose, 100 plus 50 is 150. So 33% total power is transmitted in AM. This question I am not going to clarify or not going to give you proof, but you have to understand because it is objective type question. Now it is a time to ask some questions. In India, dash modulation is used for radio transmission. My question is radio transmission. Options are frequency, amplitude, phase, none of the above. Your time has been started. Choose the right answer now. Yeah, amplitude modulation. Amplitude modulation AMs is used in radio transmission. Going to next question. In an AM wave, useful power is carried by what? Carrier, sideband, both sideband and carrier, none of the above. Your time start now. Choose the right answer. Useful power. Useful power is going in sidebands. I have already told you carrier is not taking any kind of information but using maximum power. Useful power is sidebands. Next question. In amplitude modulation, bandwidth is attached as the audio signal frequency. If low frequency you know, then what is the bandwidth? Thrice, four times, twice, none of the above. Your time has been started. Choose the right answer. Thrice, four times, twice, none of the above. twice. Don't do mistake here. Explain several times to you. Next question. Overmodulation in amplitude occurs when signal amplitude is dash dash of carrier amplitude. This dash dash means equal to, greater than, less than, none of the above. Your time start now. It is overmodulation. Think carefully. Choose right answer. Greater than. Greater than is right answer. Next. In an AM wave, the majority of power. Where is the majority power in AM? Lower sideband, upper sideband, carrier, none of the above. Your time has been started. Choose the right answer. Don't do mistake. It is very easy. Carrier. Carrier is carrying maximum power with no information. Keep it in your mind in AM. Going next. At 100% modulation, the power of each sideband is dash dash of that of carrier. 50%, 40%, 60%, 25%. Very easy, very easy. Don't do mistake here. Time started. Choose the right answer. A, B, C, D. 25% is the right answer. Don't do mistake here. So, thanks for listening for such a long time. This is end of my today's session. Modulation and need of modulation. If you really like this channel, kindly press the like button and subscribe to my channel. Have a nice day. Go for ASOC examination. Get a license. Come on band. Have a nice day. Bye bye.